In this video, we're going to be talking about Iffys, or immediately invoked function expressions. Now, they're very important, and I guarantee you that you've seen them before, and perhaps you've written them yourself. In this video, I really want to talk about what they are, what they do, why you need them, why you should know them, and describe the syntax in a way that hopefully sort of internalizes it for you, so you don't have to worry about, copying this this weird syntax from Stack Overflow every time you need an Iffy. But before we do that, I want to briefly recap the 3 ways you can make a function in JavaScript. Now, I'm sure you've probably seen the first 2, but you might not have seen the third. For the sake of completeness, I just want to show you guys all 3. So there's 3 ways to make a function in JavaScript. Well, that's not including the new object-oriented syntax from ES 2015, or the JSON notation syntax, but I just mean creating just global functions not attached to an object whatsoever. So the first way, we'll do example 8a, should not come as a surprise. 8a. This syntax is known as a function declaration. So when you see this, it is a function declaration in JavaScript. And not a whole lot else to say about it. So let's move on to the second way. So example 8b equals function, and we'll do console log 8b. This is an interesting syntax. This is a function expression. Now, what's interesting about this is we are doing 2 things with this, and we'll actually be talking a lot more about the difference between function declarations and function expressions soon here. But for now, what's interesting about it is this code differs from this code, at least insofar as the compiler sees it, because it's actually 2 parts. We're actually creating a variable using the var keyword, so it's attached to the global scope in this case because we're not in a function. So this creates a variable, and then it assigns a function expression to that variable. So you can think of this syntax as 2 bits, 2 pieces. We have the function actually being created with this function expression syntax, and then we have a variable being bound to that. Now, there's actually a third way, and at first look, it'll look like a combination of both. Now, all 3 of these things are indeed functions, and they'll behave as a function should. So I can call 8a. Notice how you can actually, Visual Studio is kind of jumping ahead with the lecture a little bit by noticing a subtle difference between example 8a and example 8b and example 8c. Notice the different symbol here. That symbol in Visual Studio Code means a function declaration, whereas these 2 symbols refer to simply variables. So we'll do example 8b and example 8c, and I can hit Control S and blah, blah, blah. It'll just work the way you expect it to. So there's 3 ways: function declaration, function expression, and a named function expression. I just want to do a quick detour because this is syntax you won't see very often, and in fact, it actually misbehaves a little bit in Internet Explorer 8 and below, which came as a surprise to nobody. And so you don't see it very often, but it's interesting. I just wanted to show it to you guys because it's actually not this plus this. And the reason is that this named function I cannot access outside of the scope. Notice how it says uncaught reference error, example 8c blah is not defined. So we see that that we've named this function expression, but we can't reference it by its name. And the name could be anything. The name is completely arbitrary. It could even be the same thing as the variable itself. It's not going to cause any conflicts. And the reason it's not going to cause any conflicts is this name, when you do a named function expression, is only accessible from within the function itself. So that's a kind of an interestingly weird thing. And it's useful really only for recursion, if you're familiar with the concept of recursion, where a function invokes itself. So I see how 8c is in scope. Now, I don't want to hit Control S and run this code because it's going to cause a Stack Overflow, because this function is going to run, and then it's going to invoke itself, and go on and go on and go on. But just remember, when you have a named function expression, you can only refer to that name from within the function itself. I guess if you really want to think about it, another benefit to using this when you have a recursive example is I'm going to go ahead and console log out example 8c, right? Be sure to remove those parentheses. And what's interesting about this is this example 8c references this name. So even if this variable was changed down the road, this code would still work. So maybe there definitely is a benefit in in using this for recursion. But this series is not about recursion. So anyway, just wanted to show you guys the 3 ways that we can create functions in JavaScript: function declaration, function expression, and named function expression. And you'll also notice, if you're paying close attention, I do terminate function expressions with semicolons. And of course, that's not necessary because semicolons are not required in JavaScript. However, if you do use semicolons, which you absolutely should use a semicolon for every situation where it's required, then it would be considered bad form, very much bad form, to omit that semicolon. The same is not true for a function declaration. For this, although it's legal to put a semicolon there, it is against stylistic guidelines. So, stuff and things. Let's go ahead and comment out example 8a or 8 and move on. We'll talk more about the differences between, by the way, these two syntaxes, the most common ways you'll see functions declared in JavaScript, later in the series, or later in the section actually, and it'll become more apparent where you should use one over the other later. But for now, just think of them as being equivalent. Anyway. Let's move on to example 9. While we talk about example 9, I want you guys to keep a couple things in your mind, and these should be things that are always in your mind when doing JavaScript scoping and figuring out where your variables live. So, what is the global scope? Why is it bad? When are scopes created and when are scopes not created? And these are things that you really need to internalize. So, let's go ahead and talk about a problem. And the problem will be solved by Iffys. Don't worry, we'll get to them in a second. And it's actually something that's that should be already pretty clear to you from our previous couple of videos. But if I went ahead, and let's say I have this file, this JavaScript file, it does a lot of awesome things, but I have this helper function somewhere that I only use in this file and don't want it to be exposed to anybody else. So let's just call it my private function. And we'll do console log, you shouldn't be able to call me outside of this function. All right, and if we hit Control S, now the problem is you probably already know the answer to this question: is this function global or is it local to this file? And obviously the answer is it is global. I can invoke this function from within my console. I don't want to be able to do that. I don't want this function to be global, because if I had another file with another function called my private function, I don't want them to compete with each other, because everything will explode and the world will end and it'll be awful. So we want to make sure that this function is private. And the problem is we're declaring this on the global scope. Obviously, if I wrap this in, like, let's say an if true, remember this isn't going to create a scope. If statements don't create scopes, I can still call my private function. I don't want this function to be available to me from the console at all, because that implies it's available to every other file in our application. So, the solution to this problem is by creating a new scope. And how do we create a new scope? Well, we create functions. So let's go ahead and comment this out and do another example here. Let's go ahead and do example 10. So, we have a problem. We need to create a new scope. We need to create a private block of memory. So let's go ahead and do that. Function example 10, and from within this, I can go ahead and say function my private function, and I can do console log I am private. And then let's come down here and let's invoke example 10. Let's actually invoke my private function within example 10 to prove that that's private. And let's hit Control S. Now we see I'm private being printed out, so we know it's private. And or we know it's accessible from within this block. But I cannot do my private function. I can no longer invoke this function from within my console. So I succeeded in hiding this function to anybody outside of example 10. But now we have a couple problems, and the first problem is obviously example 10 is not a private function. It is quite clearly accessible from the global scope. In fact, I can come down here and just do example 10, right? And example 10 still has access to I am private, but example 10 itself is not private. So that's a potential issue, but that's not the biggest issue. The biggest issue is, you know, it's kind of useless to write a JavaScript module that doesn't really expose any functionality. Imagine if jQuery didn't expose itself at all. Like, you ran all the jQuery initialization and you weren't even able to access the jQuery variable, which would make it kind of useless. So we do want to be able to selectively make certain things public. Now, right now, with this, the way this is set up, we're only able to make one thing public, which is our main wrapper function. Think of example 10 as a wrapper function, or a JavaScript module, if you will, that creates its own scope. It creates its own private scope that's not available from anywhere else. So we need a way to make a public function from within example 10. So how do we do that? Well, I can't use the function declaration. A function declaration right here will just make another private function that we can't access. So what I'm going to do is I'm going to say window dot public1 equals function. We're going to use a function expression. Console log public1. And then we can do window dot public2 as many times as we'd like. Now we can hit Control S. And so now we're using a function expression instead of a function declaration, but specifically we're attaching it to the global scope. So I can come over here and I can now type in public1 and public2. And you know what the cool thing about this is both of these public functions have access to my private function. Because remember, my private function, this function declaration, is being attached to the example 10 scope. So example 10, when it's invoked on line 179, it's creating a special block of memory. And my private function is being attached to that special block of memory. So within this public function, I can invoke my private function. I can even create local variables. I can say var I equals 10, and I can say public1 and I is plus I. Then let's do plus I plus plus. So we increment I every time that we call this. So let's hit Control S, and now we can invoke public1. And notice we get public1 and I is 10, and then I am private. Do it again. Public1 is I is 11, I am private, and so on. So we see that we've created this kind of encapsulation here where we have private variables and private functions, and it's fantastic. And we can selectively expose certain things by simply using function expressions attached to the global object, attached to the global scope. So now we're in a sort of opt-in instead of an opt-out, where we choose what we want to expose. But we still have a problem. This wrapper function has a name and is public. What do you think is going to happen? Actually, this is a cool little exercise. Maybe another good little interview question. So I'm invoking public1, 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 and I is 15, I is 16, I is 17. Now let's invoke this example 10, something you shouldn't be able to do. It's a really bad thing. I'm going to show you guys exactly how bad it is. So I'm going to invoke example 10, and nothing seemed to have happened. But what do you think the output now of public1 is? Let's go ahead and hit enter. Public1 and I is 10. Wait a sec, we invoked public1 a second ago and I was 17. Well, what happens when we invoke example 10? A new block of memory is allocated. And all these local variables get attached to the new block. And then this code gets executed. And what happens then? Our window.public1 gets replaced with a new function expression that is bound, has a binding to the variable I that was just created with a fresh block of memory because we invoked example 10. So this is awful. We have this wrapper function, this JavaScript module thingy, module pattern, whatever, but we still have this problem because it's named. So that's a problem. We need to figure out how to create a function that's not that doesn't have a name, and that is what an Iffy is. Let's think about it. Immediately invoked function expression. Now, what's a function expression? We've seen it right here. Example 8b. This is how we create a function expression. So how can we want to immediately create a function expression, but then we want to immediately invoke it so that it doesn't have a name. So let's see how we can do that. Let's start off with the syntax. Let's break down the syntax. So again, I'm sure you've seen this before, but I want to break this down. I want to break this down how the JavaScript compiler will see this and how it'll understand it. So we want to create a function without a name. So let's start off with that. Whoops, we already have an error. We cannot create a function without a name, seemingly. Problem is the JavaScript compiler thinks that this is a function declaration. Because it thinks it's a function declaration must be named. You cannot create a function declaration without a name. But if we did this, var a equals function, then we have a function expression. So we have to trick the compiler into thinking that this is a function expression. And how do we do that? Wrap it in parentheses. By doing parentheses, we have opened up a sort of context of, we are now in expression mode. We're no longer in declaration mode. We're in expression mode, where we can do things like 1 + 1 = 2, right? And because we're now in sort of expression context, we are now allowed to do function expressions. But it's not so useful, actually, at this point. I can say console log, hey there, or just hey, I guess. I forgot how to type there, apparently. So nothing's happening. Nothing's happening at all, because we're creating this function expression, but then we're just kind of throwing it away. It gets garbage collected. All the memory that was allocated for this function probably gets eventually deleted by the JavaScript garbage collector. So what we need to do is we got the second part of the IIFE. We got a function expression, but we don't have the first part. We don't have the immediately invoked. Now, how do we invoke functions? With parentheses. Hit Control S, and now our function is invoked. So what we're doing here, every part of this is now an IIFE. This is a true IIFE. First step, we trick the compiler into evaluating this as an expression and not a declaration. Without these parentheses, we would get a compiler error. Second thing we do, we create our function expression. Now that we're in expression mode, we can create a function expression. Then we close our parentheses, and then we immediately invoke it by invoking it as we would a function. And this gives us all the benefits. In fact, I can go ahead and say, function private function here. Console log I am private, and I can run this. We know this is getting called. See, this is in an IIFE. We know it's being called. We see that right there. This is in an IIFE, but we can't invoke private function, nor can we invoke the IIFE that created that private function because it has no name. You can't invoke something that has no name. Nothing was added to any scope. But we can selectively export a function. Window public 1 = function. And here I can say I have access to my private function. And I can say console log in public 1. Hit Control S. Now I can invoke public 1, both in the JavaScript console as well as any other file that we might have. So what have we essentially done? We have created a scope. When this private function is created, it is attached to this IIFE, this function keyword right here, not to the global scope. This IIFE is not attached to the global scope because it has no name. And remember, I could do that. I could name this function, but that's not going to allow me to invoke this function. Remember that a named function expression does not allow you to call it. It doesn't name that function outside of the scope, like a function declaration. And the only reason this looks exactly like a function declaration, doesn't it? Exactly. The only difference is this parenthesis. That tricks the compiler from thinking this is a function declaration into thinking it's a function expression. So giving it a name doesn't do any good. Unless you want to recursively call it, which that would be silly. Let's talk about one more thing. With this, you will often see people passing variables into IIFEs, and this is actually going to come up in a later video when we start talking about closures and how to fix the early example that we had in the introduction to this section. But we can pass parameters just fine. I can go ahead and say, I don't know, thing, and I can say console log thing, and then I can pass it in right here. I can say thing, and I'll do a string. This is a thing. Remember, these parentheses are the arguments we're passing into the function. So this is a thing, gets passed into this thing, and when I hit Control S, we get this is a thing. You'll often see this used with like a jQuery, for example. Somebody might not like jQuery using the money symbol. So what they'll do is they'll use the full word jQuery, and then they'll capture that as their preferred symbol inside of the IIFE. So outside of the IIFE, let's say we're using jQuery no conflict mode where it doesn't overwrite the money symbol. We're just using the straight up jQuery word. But in the IIFE, we want to reference it as the money symbol. Now, this is not going to do anything in this example because I don't have jQuery on the page. As you see, jQuery is not defined. But that's just how it works. You'll also see things like, let's say we don't want to do window 1 public. Let's say we want to pass in something called like global. So we do global public one, and then we pass in window as a parameter. That's another common thing that you'll see people doing. So the window is being passed in as a parameter. It's now inside of this scope, and only this scope, because remember, parameters are scoped just like local variables. Global now points to window, and you'll see that used as well in some people's style guideline. But that's it. I hope this cleared this up for you guys. I know you've seen the syntax before, maybe even written it, but I hope I broke down exactly what's going on in this context. So in the next video, we're going to talk about a silly thing in JavaScript called hoisting, and this is another thing you'll see in interview questions and is something that's very important to understand when talking about scopes, and we'll see you then.